Hello and welcome to this ITQ Lightboard video. My name is Robert Cranendonk. I'm an IT consultant at ITQ, and I'm here together with
Roy Shoham, NSX solution engineer working for VMware.
And today we're going to be talking about the Zero Trust using VMware NSX technologies.
Should we start with a formal definition of Zero Trust?
Exactly, yeah. So Zero Trust really ties into three different principles, where the first principle, it really ties into the name, is assume no trusted zones. And trusted is really the most important part.
So that's correct. It's really about seeing all traffic as something that should be verified. There are no safe zones, trusted zones. Yes.
Yeah, so regardless where you're coming from, whether it's through a VPN or you're from the internet or you're within the office, every traffic is untrusted. The second principle, and is really important as a general security principle, is the principle of least privilege.
Yes, that's correct. So we're not going to be using any domain admins to do something on a regular basis.
Yeah, so the daily driver should be the least amount of privilege you have to do your job.
Only the necessary.
Exactly. And the third principle is to log and monitor everything.
And that's really everything. So you want to have this visibility. You want to record everything that happens. This will give you basically the possibility after to act in case something happens and to also change your security configuration.
Yeah. And what's really nice about logging and monitoring everything is, say, for example, someone logs in from their daily office, so you know their IP address at a certain time. And if they suddenly log in from the other side of the world at a very different time zone, then you know this and you can act upon it. So that's why it's very important to log and monitor everything.
Correct. And so in this presentation, we're going to try to divide it into three sections, basically three pillars that we're going to be using with VMware solutions, basically to do Zero Trust. So the first step will be micro-segmentation. We're going to be doing micro-segmentation using the distributed firewall and the NSX distributed firewall.
Yep.
That's correct. The second part will be our distributed IDS/IPS that we'll present to you. And the third part will be the Advanced Threat Prevention, ATP. Yes.
Excellent.
Shall we start?
Absolutely. Let's get into it.
So the first step, micro-segmentation, is really about east-west traffic. What we're trying to do here is to prevent lateral movement. What clients might have already is macro-segmentation.
Exactly. So macro-segmentation is basically the first level any company should do. So that's just separating your environment into, for example, production environments and development environments. And then using any sort of firewall to prevent cross-traffic, so anything from the production environment is not allowed to reach the development environment. Usually development environments have a lower security posture than production does.
That's obviously not enough.
Not anymore. No, nowadays you really want to have a more granular level of control. And what you could, for example, do is separate the different groups of VMs into their application. So this would be, for example, application A, B, and this would be in its entirety application C. And these VMs all provide one service or one application. And a lot of times applications need to talk to each other. So then you would define rules between from A to B. And then you have a very granular level of control to determine what is allowed to talk to other VMs.
Correct. Maybe just a word about this granular aspect. Basically, you can deploy a policy using the IP or the MAC address, so like legacy firewall, but you can also use the name of the VM, you can use a tag, you can use the operating system that is on the VM.
Exactly.
And you can also use the user, so perhaps Active Directory users, to do what we call user identity firewall.
Yeah. One of the really powerful things about NSX is that you can also use tags. So you can define these groups of applications without having to look at the underlying network topology. So you can just assign a tag. For example, this is just tag A, tag B, tag C. But you can also go a bit deeper. So if you want to separate these into different tiers, so if you have your three-tier model, you have your web, app, and DB levels, you can just also assign a tag for each of the different layers. And then what that allows you to do is to go even a level deeper with more granular control to also define the interactions between the different tiers.
Maybe we can talk about the interaction between the VMs.
Sure. So if you have a web application that wants to talk to your application tier, you can, for example, define the port rules, for example, 443. You can also go a bit deeper into context profiles. So say, for example, TLS 1.2, and then down from the app to the database is 1433 for database level access. And then these policies you can define allows you to specify the different traffics, what is allowed, because this is an allow list type of configuration.
Yeah, it's not about just defining HTTP or HTTPS. So really it's about being more specific. Here you can see TLS 1.2. So we're making sure that the adversary cannot do a downgrade attack and force TLS 1.0. It's just this. And this is something that is very powerful. Yeah. Maybe something that we should mention about these policies that we see here, they're all enforced at the VNIC level. So there are no agents. The VM is not even aware of the fact that there's micro-segmentation underneath. Yeah. And the thing is, you only deploy the policies on the NS6 node, on the ES6 in this case, that are relevant for the specific VMs that run on this NS6 node. Exactly. So we're not going to find ourselves with like thousands of rules that are not being used. When the machine is created, you don't have to wait a couple of days for a firewall rule. It's automatically applied, and when the VM is deleted, you get rid of these rules.
Yeah. So these are a couple of different mechanics that are running. You have in the NS6 configuration something called the applied to field. So you can apply rules that are specific to this security group that you're applying, so that you don't have to run through the entire rule base for each different packet that is passing through the VNIC. And what I also really like about using, for example, tags to define these security groups is what you mentioned for the application owners, that they don't have to wait a couple of days, because this is really about empowering your application owners to define these tags to their VMs themselves. So you have a cloud consumption platform or using any sort of automation, you can create policies or rules that also apply the tags to each VM so that they are allowed to use the policies already in place without having to wait a couple of days for each rule to be created.
That's correct. Can we give some examples for tags? Perhaps one could say a PCI versus non-PCI environment, different SLAs, different application tiers. So really you can really play with that. But this is, I would say, quite it takes some time, right? It's not easy to put in place.
No, it's really complex. You have to have some deep knowledge about your environment. You have to know the different flows. Your application owners need to have a good idea of what VMs are running, what VMs belong to each application.
That's correct.
But at least there's something for that.
Exactly. So you need to map all the dependencies, right? And you need to see all these interactions between the VMs. So what we basically provide as part of each and every security license is a solution called NS6 Intelligence. And here the idea is about flow monitoring, about application discovery, seeing the relationship between the different VMs. And what we will do is we will analyze the traffic based on 24 hours, a week, perhaps a month, and then recommend rules for micro-segmentation that you can modify if you want. You can also simulate in some cases, but then you just need to publish and you have micro-segmentation in place. And this really makes everything much easier.
Nice. All right, great. So now we have determined what traffic we want to allow, what traffic we want to block. But how do we know that the traffic we have allowed is actually legitimate?
That's correct. Very often the adversary can use a legit, basically, connection to attack us. And what we're going to do here is use the distributed IDS-IPS.
Yeah.
The idea of an IDS-IPS exists in the market for quite some time, but here it's a distributed one. And basically we're going to leverage, once again, our ES6i nodes, our NS6 nodes, to reuse basically these resources that are quite expensive, the CPU and the RAM, so that they can act as IDS-IPS sensors.
So we don't have to deploy an additional appliance for this feature.
Exactly. We don't need to do any hairpinning and make all the traffic go through a physical box.
Nice.
Great. So let's start. Basically, IDS-IPS, we have two options. Either we will detect the traffic or we will block the traffic. We'll do this using signatures, basically, to detect all sorts of behaviors, patterns, attacks. And we will deploy, we will basically give signatures with a certain action by default, either to detect or prevent, but the customer can always change it. There's this global signature set where you can view all the thousands of signatures that are being basically updated quite often, every few minutes or so. But
Can you also update that when you're in an air-gapped network?
I saw that question coming. So in an air-gapped environment, you can always upload your signatures in a manual mode. Yes.
Nice.
Great. So it's not just, I would say, the signature-based, but there's also the behavioral part. Do you know what it means? Have you heard about it?
So from context, I would guess that, say, for example, if you have SMB traffic allowed, you would detect normal traffic versus abnormal traffic.
PSExec, exactly. Perhaps failure, high failure rate in authentication, things that, all sorts of anomalies, things that you would like to check. So that's the behavioral part. Here we're leveraging machine learning algorithms. So it's not just about signatures. Yes, yes.
Cool.
You know, it's really useful, for example, for virtual patching. So you take Log4j a couple of years ago, what we were able to do is to very quickly publish signatures, and more than just a few signatures against Log4j, all the different techniques, allowing basically customers that didn't have the time to patch their environment to sleep at night, basically give them some peace, because it takes time. It's something that takes time, and
especially if you're dependent on a different vendor or, you know, God forbid, open source.
Exactly.
Waiting for them to update their Log4j deployments.
We were quite fast in this case.
Nice.
And we have our threat intelligence unit that basically are supporting us and publishing all sorts of signatures. What we really like here is basically the flexibility. So once again, you deploy these policies only on some of the nodes or on all of the environment, but these will be policies that are relevant only for the VMs that are present on this ES6i.
Oh, okay.
So you can be very specific with that and apply only signatures that are relevant for web application, SQL, VDI environment, for example.
Oh, nice.
So we see that quite often.
Cool.
Yes.
Sounds good. Okay. So now we know what traffic we want to allow, what traffic we want to block. We know whether or not it's legitimate. Well, what can we do to go a step deeper into our defense in depth strategy?
Great. So in this third step, basically, we're going to talk about advanced threat prevention. Sure. I would say it's the more advanced functionalities that you can have in order to protect your environment. And it includes a couple of solutions. The first one is malware prevention.
Okay.
Maybe we can do a drawing here. The idea here, it's about detecting malicious files. So we're talking about VMs within your data center. We're going to be leveraging VMware tools to detect all sorts of attempts to download a malicious file.
Cool. So not another agent required?
Exactly. Cool. Not another agent. What we're going to do, we're going to try to distinguish between known good and known bad, if we are able to do that. If we don't know, we're going to send it into our sandboxing event where we will emulate basically and execute the file, so we can give you an answer whether it's a safe one or not. So I would say this is sort of like where we would have it. That's the first step, malicious files, malware prevention. From there, what we want to do is also inspect the traffic to detect for anomalies. We're going to network traffic analysis. Maybe you've heard about it.
Absolutely.
Solution that is composed out of 14 detectors, where we're going to try to detect all sorts of things, like port scans, for example. Okay, horizontal, vertical port scans. It's not necessarily an attack, but it's something that you want to check. It's something that you want to verify.
It also can be indicative of an attack.
Exactly.
In progress. Yeah.
Exactly. It's something that the engineer would like to check, verify. DGA, the user is trying to leave towards a very strange domain.
Yeah, so domain DNS generation algorithm.
Exactly.
Created by malware.
Something that you want to check with the network traffic analysis. Also port beaconing and so on. So you have these two solutions. That's great. But what happens when you go through an attack and you need to react as soon as possible? How do you make sure that you get the full picture, something that makes sense? And that's where network detection and response gets into the picture. If we're talking about all these solutions, this is part of an acquisition that was made a few years ago, a last line acquisition that today, as you can see, its products are integrated, really fully integrated into the NSX platform.
Nice.
Yes, network detection and response. We're going to try to take all these events from the IDS, IPS, from the malware prevention, from the distributed firewall, NTA, and give you something that makes sense, correlate it real time into what we call a campaign.
Okay. So you really get all the different information from all the different products on all the different monitors.
Exactly. You get the full visibility of all these things that are happening here to see where you're standing with respect to the attack. We're going to be, just important to mention, we're going to be mapping everything that happens, whether it's in the first part, micro-segmentation, IDS, IPS, and here, we're going to be mapping these events to the MITRE framework to give the engineer something that they can use, they can leverage.
Really helps with the communication as well.
Exactly. And you get the visibility to know where you're standing with respect to the attack. Are you in a step of lateral movement? Perhaps there is a command and control attempt, or we're already talking about exfiltration using perhaps a DNS tunnel or so.
Okay, so you really know where you are within that attack, and can you also point to for example, a 0 point, the point of entry? So the patient zero, so to speak?
Exactly. You can really see, so you get sort of like a map with all the VMs, and you can see how the interaction happened. It's really, really interesting to see.
Sounds good. All right, that all sounds very good. Let's talk about some obstacles and enablers for your Zero Trust journey.
Great. So if we're talking about obstacles, one of the first things that we see that prevent an organization from putting in place a Zero Trust strategy is silos.
Oh, yeah.
There's very often a lot of silos between the different teams, the network team,
storage team,
exactly. They don't
team.
talk to each other.
Yeah.
You want to make sure that there's a full cooperation between these teams.
Yeah, because the Zero Trust journey is really as much a technological journey as it is an organizational journey.
Correct.
Yeah.
Correct. And then other than silos, we can talk about visibility and monitoring.
Yeah, so this really ties into the third principle of Zero Trust, log and monitor everything. Exactly. So you need to know from A to Z what is happening in your environment.
Exactly. End-to-end visibility when you need to troubleshoot, when you need to react because you're going through an attack. Something that can help here is NS6 intelligence for the rule recommendations that we've mentioned, but also ARIA operations for a network, known as VRNI as well. It's about really having this visibility between on-prem or cloud environments where you can really see the switches and the load balancers and the flow from one VM to another.
Yeah.
So that's another.
Virtual and physical.
Exactly.
Yeah.
Tools. We see with customers that have a lot of tools. Now, this is difficult because it's about integration. It's about compatibility between all the tools. Different teams have different tools, How does it work together? Usually it doesn't.
And they never interact like you want it to.
Exactly.
Absolutely.
Correct. And it's about the attack surface. If you have a lot of tools, and here we talked about NS6, it's one solution. If you have many tools, you're very much exposed.
Absolutely. Yeah. So enablers.
Yes.
How do we make it better?
Well, great question. I would say start with ensuring resources.
Yep.
Whether it's FTEs, you can just take your engineer that is already working 100% and say, okay, now you're helping us with the Zero Trust.
Yeah, just add it on there, more load.
It usually doesn't work. No. Or also budget, maybe there'll be solutions or other services that you will need. You want to make sure that you have the resources.
Yeah.
Then communication. So you need to know your users. You need to communicate between the different teams. I would say try to see how the end users are using the different applications in your environment. Talk to the developers so you can know what sits behind this VM with a generic name.
Absolutely.
Okay.
And finally, you need to know what success looks like.
Exactly. You want to define KPIs. You want to see what good looks like. It's a journey, right? You might have to adapt to modify these KPIs, but you need to start with it so you can know how your progress looks like.
Yeah. What's the end goal? What's the dot on the horizon that you want to go to?
Exactly.
Yeah. So how do we get there using VMware?
Why VMware NS6 when it comes to Zero Trust? The first of all is about the fact that there is no re-IP. We don't need to rechange, modify, or do anything to our network. We can leverage a brownfield environment. We mentioned the distributed port groups, the subnets that you already have.
Existing VLANs, existing infrastructure, no changes.
Exactly. Yeah. Now, another point is about overlay. You don't need to leverage overlay segments from NS6. It's separated. We do propose that with NS6, but it's not necessary here when we talk about security, and also licenses are separated.
There are a lot of benefits to using overlay, but they're not necessary for the security.
Exactly.
Cool.
We said no agents.
Yep.
Right? No agents. Here it's about the fact that the VM is not aware that there is an underlying solution, and no one can turn off, for example, the agent and so. Another point that we should mention here as a benefit with VMware NSX is that it's one solution.
Yeah.
So really one solution where you can basically apply and define and configure policies for your VMs, but also for containers. We should also mention that, have you heard about Entrea? So that's our one of the CNIs that we're working with, where you can guarantee this consistency and this quality that you have with VMs, also in the container world. Distributed firewall, also some more advanced functionalities like IDS, IPS. That's really exciting. And yes, we see a lot of customers using that. So
excellent.
We said one solution. And yes, I think with this, we can really, I think the last point that I would talk here, it's about acceleration of application deployment.
Oh yeah, so automation, everything uses APIs that we talked about.
Exactly. So we're talking about app deployment. And here it's, you don't need to wait a couple of days for an IP, no tickets. So it's much more efficient.
So life cycling becomes much faster.
Exactly.
All right.
Great.
That all sounds very good.
Hey, thank you very much.
Cool to hear. Yeah. So thank you all for watching this Lightboard video. If you have any questions or comments, reach out to us at IDQ or VMware. And have a great day, and thank you very much.
Thank you.